Before overhauling the engine, it is desirable to carry out a preliminary inspection to ascertain whether an engine overhaul is really necessary. The most common reasons for which an engine is overhauled are insufficient power, high engine oil consumption, low engine oil pressure, and mechanical knock or noise.
Apart from poor engine compression, the loss of power can also be due to faulty fuel system, clutch slippage and binding brakes. If you ascertain that the loss of power is not on account of these, you can check the compression pressure.
Before starting the test, ensure that the battery and self-starter are in good condition so that the engine cranking speed is 150 to 200 RPM. Retorque the cylinder head bolt to specification. Check valve clearances on both inlet and exhaust as per specification. Warm up the engine to operating temperature 68 to 86 degrees centigrade. Remove all injectors and fit the dummy injector into the first cylinder. And then connect the compressor gauge with a flexible pipe to the dummy injector, ensuring that the clamp for the dummy injector is properly tightened and the vent knob of the gauge is in the closed position. Crank the engine with the self-starter. Ensure that the stop lever is pulled so that diesel does not come out from the FI pump. Read the compression pressure on the gauge and record the same. Loosen the vent knob so that the gauge needle returns to zero. Then tighten the knob again and repeat the procedure on the other cylinders. The compression pressure should be 22.85 plus or minus 3.5 kilograms per centimeter square in each cylinder for a healthy engine. The maximum variation in compression pressure of cylinders should not exceed 1.5 kilograms per centimeter square. If the compression pressure of one or more cylinder is below 18 kilograms per centimeter square, it's generally found that starting trouble, loss of power, increased fuel and engine oil consumption, and heavy smoke necessitates engine overhaul. To ascertain whether the leakage of compression is from the valve or from the piston rings, pour a little oil into the defective cylinder and then check the engine compression pressure as described earlier. If compression pressure improves, wear in the piston ring and cylinder bore is indicated. If compression pressure is unaltered after pouring oil, it indicates leakage past the valves. And if the compression pressure of two adjacent cylinders read on the lower side, it may be due to a blown cylinder head gasket. For high engine oil consumption, low engine oil pressure, and for engine knock or noise, the normal procedure should be followed as described in Escort Tractor Training Manual. Refer page number 31.
After ascertaining that this engine of Escort 340 needs to be overhauled, it has been brought to the workshop and mounted on a work stand. Before bringing it here, the water connections, fuel connection and electricals were removed. Now before starting the dismantling, we have to first drain the engine oil.
To do so, unscrew the drain plug of the oil sump with a 30mm ring spanner. After the oil is drained, refit the drain plug. The next step is to unscrew the cylinder head cover mounting nuts with a ring spanner of 13mm. Lift the cover and place it on a table. Check the rubber gasket. It can be reused if it is not damaged. Next, unscrew the rocker shaft bracket nut with a 17mm ring spanner and remove the assembly and keep it properly. Remove the push rods and place them in order. They should be returned to the exact place because of their wear pattern. To remove the overflow pipe, unscrew the banjo bolts. Next, loosen the nuts on both ends of the high pressure pipes and remove all the pipes from the injectors. Remove the injectors one by one. Check the washers and keep them in a proper place. Loosen the nuts of the exhaust manifold, remove it and keep it properly. Next, loosen the nuts of the intake manifold and remove it from the cylinder head. Remember to place it properly. To remove the cylinder head assembly, take a long handle and a socket wrench of 19 millimeters. First, loosen all the bolts and then, either with an impact wrench or a speed handle, remove all the 14 bolts. Lift the cylinder head assembly and keep it properly. Remove the cylinder head gasket and dispose the same. Loosen the engine oil filter with a filter wrench and then remove the filter by turning it with the hand. Loosen the 3 mounting bolts of the oil filter body with a 14 mm spanner and then remove the same. Loosen the water pump assembly bolts with a 13 mm socket and speed handle and remove it. Turn the engine upside down for the following steps. Now, step number 13 is to loosen all the bolts of the oil sump with a 13 and a 17 mm socket and a speed handle. Remove the sump and keep it properly. Unlock the 2 mounting bolts of the oil pump assembly. Loosen the bolts with a socket of 14 mm and T-handle. Then unscrew the pipe nut with an open-ended 22 mm spanner and remove the oil pump assembly. Take care of the shims. After that, lock the flywheel and with a 17 mm socket and T-handle, unscrew all the 3 bolts and remove the pulley. Using a 13 mm socket and speed handle, unscrew the bolts and remove the timing gear housing cover. Before removing the timing gears, check the backlash between intermediate gear to camshaft gear, intermediate gear to crankshaft gear, and intermediate gear to FI pump gear. Unscrew the 3 mounting bolts of the FI pump gear with a 13 mm socket and T-handle, and then remove the gear. Check the gears for any damage and replace if the teeth are found chipped or having excessive backlash. Now, loosen the 2 mounting bolts of the intermediate gears with a 13 mm socket and handle, and then remove the gear. Check the end float before removing the camshaft. The end float should be 0.27 to 0.44 millimeters. Next, align the thrust plate bolt of the camshaft and unscrew the bolt with a 14 mm socket and handle. Remove the camshaft assembly with the gear by rotating and pulling it out from the bore. Take care that the lobes of the camshaft are not damaged. After removal of the camshaft, remove all the tappets in sequence. Remember to keep them in the same order. Now, remove the 4 mounting bolts of the FI pump assembly with a 13 mm socket and handle. Take out the FI pump assembly. The FI pump and 3 injectors should be sent to an authorized micro dealer for overhauling and recalibration. Step number 23 is to unlock the mounting bolts of the timing gear housing. Before removing the flywheel, first loosen the bolts of the pressure plate assembly and then remove it with the clutch plate. Turn the engine. Before removal of the piston assembly, remove the wear ridge at the top of the cylinder bore with a ridge cutter. This will help in easy removal of the pistons and will also prevent damage to the piston ring groove. Now, turn the engine so that the piston you are working on is at the bottom of its stroke. Loosen the connecting rod bearing cap bolt by using a 17mm socket and T-handle. Tap the cap with a mallet and lift the cap with the bearing shell. Turn the crankshaft till the piston is at the top of its stroke. Now, carefully push out the connecting rod and piston assembly from the cylinder block with the help of a hammer handle. Match the number punched on the connecting rod and the cap. Remove all the pistons one by one and keep them in a wooden box to prevent damage. Now, unlock the flywheel bolts, loosen them with a 19mm socket and handle, and then remove the flywheel with a special service tool. Unlock the bolts of the bell housing, loosen all the bolts with a 19mm socket, extension and T-handle, and then remove the bell housing. Remove the oil thrower from the crankshaft. Then loosen all the main bearing bolts with a 24mm socket and a long handle. Remove all the caps and lift the crankshaft. Using precision measuring gauges will give correct measurements, and special service tools will facilitate easy removal and assembly. Impact wrench facilitates fast loosening and tightening of nuts and bolts. Clean the cylinder bore thoroughly and check wear by means of a bore gauge. Set the bore gauge to 0 and then measure the bore in 4 places in 2 directions, parallel to the engine and crosswise. Record the measurement on the engine inspection sheet. If the cylinder bore is scored or otherwise damaged and is worn beyond permissible value, replace it with a new one. Using special service tool number EO2500, remove all the liners one by one. Check the cylinder block surface for unevenness with the help of a straight edge and a feeler gauge. Flatness of top surface is 0.04 mm and should be checked on 4 sides and 2 diagonals. Check with a micrometer the outside diameter of the intermediate gear shaft, and then check the bore with a telescope gauge and a micrometer. Replace the intermediate gear bush for an oversized one when maximum permissible play between bush and shaft is exceeded. Remove the gear from the camshaft, place it on 2 V-blocks, and with the help of a dial gauge and stand, check the runout. If it exceeds 0.05 mm, replace it. Check the camshaft lobes for any damage. Replace it if found necessary. Check the camshaft journal diameter with a micrometer and record the same. Check the cam bush inner diameter inside the cylinder block with a bore gauge. Replace the bush after having ascertained excessive clearance between the bush and the camshaft journal. Machine the bush following fitting to the repair size. This can be done at the machine shop. With the help of a valve spring pressing tool, press the spring and remove the collets. Remove the tool and remove both outer and inner springs with the retainer. Then remove the valves and clean them. Check valve condition. Burnt, cracked and eroded valves must be discarded. Slightly pitted valves can be reused. Place them in order and then check each valve stem diameter with a micrometer. The valve guide bore can be checked with the help of a dial gauge and a magnetic stand. Set the dial gauge to 0 and then move the valve stem from side to side and read the dial gauge. The bore can also be checked with a telescope gauge. Insert the gauge inside and lock it. Then measure it with a micrometer. Check valve seat and its angle. If damaged, the seats can be replaced with a new one and cut with a valve seat cutter to the required angle. Finish by lapping with emery paste. Check valve leakage with kerosene or petrol after lapping. Now check valve springs for cracks and squareness, and then check the free length with a vernier caliper. Measure valve tension with the help of a spring tester. If the measured value is less than the specified limit, valve springs must be discarded and new ones installed. The collets should also be checked and replaced if found damaged. Dismantle the rocker arm assembly, remove the lock and remove the rockers from the shaft. Inspect the rocker arms for surface step. If it has a light step or scoring, it can be ground on a grinding stone. If the step is severe, the rocker must be discarded. Check the rocker bushes with a telescope gauge and micrometer and replace them with a new one if worn out. Check the rocker shafts for seizure and scoring marks. Check the shaft diameter with a micrometer. Place the rocker arm shaft on a V-block and with a dial gauge measure the runout. If the runout is slight out of round, correct it with a bench press and recheck it. The next step is to check cylinder head flatness with a straight edge and a feeler gauge on 6 sides and 2 diagonals. Maximum permissible outer flatness of cylinder head face is 0.02 millimeters. If excessive, repair by refacing it. Check all push rods for straightness on a surface plate with a feeler gauge. Discard the bent push rods. Tappets should not have any cracks, peeling or pits. Replace tappets which show excessive wear, ovality, taper or seizure marks. Remove minor surface damage with use of emery paper. Keep the tappets in sequence as they were removed and return to the same bore because of their wear pattern. Check the piston for external damage and cracks. Then hold the piston with a connecting rod in a vise. Use a soft jaw or wrap the connecting rod with shop cloth. Remove the rings with a ring expander and clean with a brush and diesel. Clean the ring groove with a ring groove cleaner. Do not use a wire brush on the ring groove. Check all the ring to groove clearances using a new ring with the help of a feeler gauge. If it is too large, discard the piston. Remove the circlip and tap the piston pin out from the piston. Measure the piston diameter at the piston skirt. Check the gudgeon pin diameter in the center with the help of a micrometer. Replace it if it is worn out. Check the gudgeon pin bush in the connecting rod with the help of a telescope gauge and a micrometer. The pin should be free in the bush. If it is too loose, replace the bush. Now, check the connecting rod alignment in the alignment gauge for bend and twist. Permissible bend and twist is 0.05 millimeters. Check the removed crankshaft for any crack with the help of a magnifying glass. Also check for journal scoring or signs of overheating. Mount the crankshaft on a V-block and measure the runout with a dial gauge mounted on a stand. Gently rotate the crankshaft. Read the dial gauge as you turn the crankshaft. The runout should be within 0.04 millimeters. Measure all the bearing journals with the help of a micrometer. Measure the ovality and taper at 2 cross sections in the perpendicular planes. Regrind the journals in the course of repair to the next underside. Please refer Escort Tractor Training Manual, page number 85. The extent of regrinding depends on the most worn journal. After regrinding the journals, check the fillet radius with a radius gauge. Maintenance of fillet radius is very important. The steps formed after regrinding will lead to breakage of the crankshaft due to stress concentration. Refit the main bearing caps with the bearing shell. Retorque the main bearing cap bolts as specified. Check the main bearing inner diameter with the help of a bore gauge and then measure the bore in 3 directions to find out clearance between main bearing journal and bearing inside diameter. Record the same in the inspection sheet. Now, fit the big end bearing shells in the connecting rod and hold the connecting rod in the vise. Measure the bearing inside diameter with the help of a bore gauge. Discard the bearing if excessively worn out. Also, replace the bearings which have signs of scratches, cracks or metal peeling. Replace the bearings to the next size as per the ground crankshaft journal. Check oil pump gear and radial backlash with the help of a feeler gauge. If the radial backlash is more, then replace the oil pump. Check the side surface of the gears with a feeler gauge and a straight edge. Also check the cover plate flatness with a straight edge. The scoring marks on the cover plate can be removed by regrinding. Check the valve plunger. It should move freely in the bore. Also check the valve spring. Replace it if necessary. Reassemble the spring and plunger by pressing an adjusting tube and fixing it with a split pin. Hold the water pump in a vise. Loosen the nut from the shaft and take out the pulley from the shaft with the help of special service tool EF0300. Remove the woodruff key and then the shaft assembly by hitting it with a soft hammer towards the impeller end. Take out the seal assembly and thrust ring carefully. Check for any scratch on the shaft, corrosion traces and pitting on the bush. Remember to check the bearing for noise and also repair the seat and replace the seal. Tools should be placed properly in the allocated place for easy access. And remember, use only millimeter-sized spanners. Maintain exceptional cleanliness throughout reassembling the engine components. It is extremely important that all work is done in a completely clean location. The engine assembly will start after discarding the worn-out parts. Wherever possible, apply Loctite 262 for firm locking of nuts and bolts. Remount the engine on a work stand. Clean all the oil passages using compressed air for drying. Lubricate the tappets and fit them in the cylinder block tappet bore. Check for free movement of tappets in the bore. Fit the intermediate gear shaft. Then replace the main bearing shell and lubricate it. Place the thrust ring in the respective bearing seat. And then place the crankshaft. Rotate it with the hand to ensure proper seating. Fit bearing shell on the main bearing caps. Lubricate the bearings. Ensure that the locating lug on the bearing shells are on the same side. Also fit the thrust ring in the fourth main bearing cap. Mount the main bearing caps, lubricate the bolts, and then tighten the bolts with a 24mm socket in sequence of center bolts first and then side bolts crosswise. Before torquing any bolt or nut, set the torque wrench to the required torque. Torque the main bearing cap bolts with a torque wrench to 24 to 26 kilograms meter. The crankshaft should rotate freely when rotated with the hand. Check the crankshaft end float. It should be between 0.22 to 0.49 millimeters. This can be done with the help of a magnetic stand and dial gauge. First, apply shellac on the timing gear housing and then put a gasket on it. Place the timing gear housing on the cylinder block, positioning it on the gasket with a dowel. Tighten the timing gear housing with 4 bolts and tab washers. Torque the same and bend the washer. Place the thrust flange on the camshaft on the gear end. Then insert the woodruff key in the key slot and press. Place camshaft gear matching the keyway. Press fit the gear on the camshaft and then lubricate the camshaft journals and the cam bush inside the block. Insert the camshaft into the bore. Align the thrust flange and then tighten the 2 bolts and washers on the thrust flange to a torque of 2 to 2.5 kilograms meter. The camshaft should rotate freely. Check camshaft end float with a dial gauge. Tighten the tacho drive unit. Now turn the engine. Fit 2 silicone rings on the cylinder liner. Dip the rings in caustic soda solution and then fit the liner into the cylinder block. Check cylinder liner protrusion above the cylinder block with the help of a straight edge and feeler gauge. The protrusion should be 0.06 to 0.11 millimeters. The protrusion should be checked by placing 2 piston pins pressing the flange of the liner. Another method of checking cylinder liner protrusion is with a dial gauge and a stand. Taking care that the arrow mark on the piston crown is aligned with the dimple on the connecting rod, place the small end inside the piston, aligning with the piston boss. Insert the gudgeon pin in the piston connecting rod assembly with the help of a drift. Insert circlip on both sides of the gudgeon pin in the circlip groove. Rotate the circlip for ensuring proper seating in the groove. Ensure that the opening is either on the top or bottom side. Check the end float of the connecting rod small end with respect to the piston boss. It should be between 0.2 to 0.5 millimeters. Before fitting the rings on the piston, check the butt gap, taking care that the ring is squarely placed while pushing it with a piston. Check the butt gap of each new piston ring in the respective bore at an unworn area. In this case, it is at the top because the liner is new. Hold the piston and connecting rod assembly in a vise. Wrap a work cloth around the connecting rod. Ensure that the end gap of the oil ring coil expander is opposite to the oil ring butt gap. After fitting the oil ring coil expander on the third oil groove, then with the help of a ring expander, fit the oil ring on the same groove. Always ensure that the top marking on all the compression rings are fitted towards the top side of the piston. If it is fitted the other way round, engine oil will escape through the rings to the top and result in excessive oil consumption. Fit the second compression ring. The top ring is a chrome-plated ring and is to be fitted in the top groove only. Repeat the ring fitting procedure on the other remaining pistons. Arrange the butt gap 180 degrees apart so that the butt gaps of the rings are not in one line. Ensure that the crimp on the ring compressor is facing downwards to prevent it from going into the bore. Tighten the ring compressor onto the piston. Loosen and remove the connecting rod bolt and remove the cap. Fit the big end bearing shell in the connecting rod big end bearing seat. Fit the 3 pulley bolts to rotate the crankshaft. Ensure that the dimple on the connecting rod is facing towards the front of the engine. Lubricate the bearings and inside the cylinder liner with clean engine oil. After lubricating the bore, push the piston into the bore. Rotate the crankshaft with a handle and keep pressing the piston with a hammer handle until it is at BDC position. Ensure that the locating lugs on the bearing shells are on the same side. Fit the connecting rod cap on the crank pin with the bolt. Tighten the bolts with a 17mm socket and impact wrench for faster tightening. Then torque to required specification. Repeat this operation with the other pistons and connecting rods. Check the piston protrusion above the cylinder block surface with a stand and dial gauge. Fit the intermediate gear on the gear shaft, matching the S mark of the camshaft gear with intermediate gear, and also the crankshaft gear with the intermediate gear. This will ensure the position of the first piston at TDC. Put a thrust plate and 2 bolts and tighten it. Check the end play, which should be a maximum of 0.2 millimeters, with a feeler gauge or a dial gauge. Torque the bolt to the required torque of 2 to 2.5 kilograms meter. Apply grease on the FI pump mounting face and put a gasket on it. Fit the pump on the timing gear housing with 4 sets of bolts, nuts and washers and then tighten them. Then fit the timing gear on the FI pump hub and match the 0 mark on the intermediate gear with the 0 mark on the FI pump gear. Fit with 3 bolts and washers. Next, fit the oil pump drive gear on the crankshaft. Fit an oil seal on the timing cover. Fit the cover on the housing and then tighten it with a 13mm socket and torque to 2 to 2.5 kilograms meter. Fit the crank pulley on the crankshaft with 3 bolts using a 17mm socket. Then tighten them to 4 to 4.5 kilograms meter torque. Fit the oil pump assembly with 2 screws and tab washers. Put the shims under the pump assembly to obtain required backlash of 0.2 to 0.34 millimeters between drive and driven gear. Tighten the bolt and delivery pipe nut with the block. Refit the oil thrower on the crankshaft. Fit the crankshaft rear oil seal on the bell housing with the help of special tool EO0101. Put a gasket on the cylinder block rear face and then tighten the bolts with a 19mm socket and T-handle and long extension. Torque to 12.5 to 13.5 kilograms meter. Bend the tab washers. Put a oil sump gasket on the cylinder block and then put the oil sump on it and tighten the bolts, then torque to required specification. Fit the dipstick and the drain plug. Fit the plate on each valve guide. Then insert the valves in the respective guides. To avoid seal lip damage while fixing the valve stem seal onto the valve, apply a round of tape on the collet groove. Then slide the seal onto the valve and push it till it sits on the valve guide step. Assemble the valves with inner and outer springs, retainer and collets with the help of a spring pressing tool. Check the valve face depth from the cylinder head face with a dial gauge and stand. The depth for inlet valve should be 1 to 1.3 millimeters and for exhaust 0.7 to 1 millimeter. Check the valve with kerosene or petrol to detect leakage. Place a cylinder head gasket on the block. Then fit the cylinder head assembly on the cylinder block and tighten the bolts to 18 to 19 kilograms meter torque in sequence. Fit all the injectors in the cylinder head and tighten the clamp nut. Fit intake and exhaust manifold with gasket and tighten the nuts to the specified torque. Fit all the high pressure pipes, connecting injectors and FI pump and then clamp the pipes properly. Fit the overflow pipe on the injector with a copper washer and banjo bolts. Replace the push rods to the exact place as where they were removed from. Assemble the rocker arm on the shaft and then fit the rocker arm assembly on the cylinder head, aligning push rods and then tighten the nuts of the stud bracket to a torque of 4 to 4.5 kilograms meter. Ensure that the cut mark on the rocker shaft is facing down. This will help the oil to reach the rockers. Crank the engine to adjust tappet clearance. Inlet 0.3 millimeters and exhaust 0.4 millimeters. Put a rubber gasket on the cylinder head cover assembly and then place it on the cylinder head. Tighten the nuts. Put a gasket on the cylinder block for the water pump and tighten the bolts. Place the thermostat housing with the valve and fit a rubber hose. After press fitting the pilot bearing, then fit the flywheel on the dowel of the crankshaft. Fit bolts with locking plate on the flywheel and tighten the same with a torque of 10 to 12 kilograms meter. Bend the lock with a chisel and hammer. Place the engine in a vertical position and check the run out with a dial gauge and magnetic stand. Should be within 0.25 millimeters. Finally, fit the oil filter body and a new engine oil filter. Fill with fresh engine oil in the sump. More accurate fuel injection timing is set by spill cutoff method using swan neck pipe on number 1 delivery valve holder after removing the delivery valve spring and peg. Remove the timing gear inspection cover and the timing pin from the flywheel housing. Rotate the engine clockwise and observe the zero mark on the fuel injection pump gear teeth. When the zero mark on the pump gear and intermediate gear teeth are about a little away from meshing, insert the longer end of the timing pin into the flywheel housing. Now, Slowly rotate the engine clockwise to the point where the timing pin can go fully into the first hole in the flywheel and slide easily. This hole is at 18 degrees before top dead center for the first piston of E340. After removing the inspection cover, pull the fuel shutoff rod to the point where the control rod quadrant is visible and slightly forward of the middle position. Temporarily fix fuel shutoff rod in this position and proceed with fuel injection timing. Remove the cylinder high pressure pipe and the delivery valve holder after loosening the holder clamp. Remove the delivery valve spring and peg and refit the delivery valve holder. Fit the swan neck pipe. Insert a piece of cloth in the timing inspection hole towards the intermediate gear to protect any part or tool falling in the timing housing accidentally. Loosen the 3 pump gear mounting bolts using a 13mm socket and handle. Rotate the pump shaft hub clockwise using a 19mm socket and handle. Keep operating the hand priming pump. A stream of diesel will flow through the swan neck pipe. A point will come when the diesel stream will reduce into drops. Carefully turn the pump shaft hub further clockwise till the point where drops fall at an interval of about 15 seconds. Holding the pump hub at this position, tighten the pump gear mounting bolts securely. Check the 0 on the gear of the FI pump aligning with the cut of the hub. Recheck timing by first taking out the timing pin and then turning the crankshaft anti-clockwise. Drops will appear from the swan neck pipe. Now turn the shaft clockwise till the drops reduce again to about a drop every 15 seconds. Insert the pin to ascertain the correct timing. Complete the job and refit the FI pump gear cover. The assembled engine is now mounted on the tractor. After mounting the engine, it is started. The oil pressure is checked at hot idling and maximum engine RPM. There is no smoke when the engine is revved up. Now, the tractor is ready for delivery to the customer.